Have you ever found yourself wondering why you might choose to scroll through your phone instead of, say, finishing up that report? Or maybe why a student in a classroom acts out instead of focusing on their work? Well, today we're going to dive into the matching law. It's a really powerful principle that explains the science behind the choices we make. At its core, this is one of the big questions behavior analysis tries to answer. Our choices, from the little things we do every day to more complex behaviors, can sometimes feel, well, random. But what if they aren't? What if they actually follow a predictable, even mathematical law? To see what I mean, let's picture a student in a classroom. They've got a choice to make. They can either focus on their math problems or they can chat with their friend. Now, if they do the work, they might get a gold star from the teacher. But if they talk to their friend, they get an immediate laugh, a shared secret. In every single moment, that student is deciding where to allocate their behavior. And this is exactly where the matching law comes into play. It's a fantastic tool that helps us understand that our choices aren't just happening by chance. No, they're actually quite predictable, and they tend to follow certain rules based on our past experiences. Okay, so here's the formal definition. The matching law is a quantitative principle. It states that when we have a few different options available, the amount of time and effort we spend on each one is directly proportional to how much reinforcement or how much of a reward we get from it. Or to put it much more simply, our behavior follows the reinforcement. It's that straightforward. If one action gives us more or better rewards than another, we're naturally just going to do more of that action. This is really the heart of the matching law. In the field, we call this response allocation. And it's just a scientific way of saying how we divide up our behavior. Think about it like having a daily budget for your time and energy. You have to decide how you're going to spend it, and the matching law helps us predict how those decisions get made. So let's take a look at how this idea gets turned into a predictive formula. Because the real power of the matching law is that it's not just a concept. It's an actual mathematical equation that can help us quantify and predict choices pretty accurately. Now, I know this might look a little complicated at first glance, but it's actually pretty straightforward. Here, B just stands for behavior, and R stands for reinforcement. All this equation is saying is that the proportion of time you spend on one behavior will match the proportion of reinforcement you get from it. So, if one option gives you, say, 70% of the total available rewards, the law predicts you'll spend about 70% of your time on that option. Let's make this a little more concrete with a simple analogy. Imagine you're standing in front of two vending machines. They both sell your favorite snack, but one of them is running a special 2-for-1 deal. Which machine are you probably going to spend your money on? This illustrates the idea perfectly. If machine A gives you 2 snacks for your dollar and machine B only gives you 1, the matching law predicts that you'll allocate twice as much of your money, which is your behavior in this case, to machine A. Now, you probably won't ignore machine B entirely, but you'll distribute your responses in proportion to the payoff. Okay, so in a perfect world, our choices would always match the reinforcement rates perfectly. But, of course, real life is a lot messier than that. Sometimes our choices don't line up exactly, and understanding why that happens is just as important as understanding the law itself. These deviations from perfect matching aren't random either. They actually follow predictable patterns. For example, there's undermatching. That's when we're less sensitive to the better option than the law predicts. Think about switching channels too often instead of sticking with the show you like best. Then there's overmatching, which is the opposite. We stick with the better option more than predicted, maybe because switching is too much effort. And finally, there's bias, which is simply a preference for one option over the other, regardless of the reinforcement. Maybe you just always prefer the blue cup. And this is where the matching law really shines as a practical tool for change. Because if we can understand why someone is making a particular choice, we can start to rearrange the environment to make a better choice the more appealing, more reinforcing one. This understanding leads to a really important shift in strategy. Instead of just focusing on stopping a problem behavior, we start asking, what should the person be doing instead? The goal becomes building up an alternative behavior, making it so rewarding that it naturally starts to win out over the problem behavior. We call this a constructional approach. So how does this work in practice? Well, first, an analyst assesses all the competing behaviors, what we call the behavioral marketplace. Second, they work to enrich the reinforcement for the desired alternative behavior. That might mean making the reward better, more frequent, or more immediate. And third, they try to make the problem behavior less efficient, often by reducing how often it gets reinforced. So when you put it all together, the matching law gives us a really powerful data-driven framework. It helps us predict behavior, it helps us understand why challenging behaviors continue to happen, and it gives us a clear path for creating effective interventions that lead to positive change. And that leaves us with a final, really powerful thought. The matching law shows us that choice isn't some mysterious, unknowable thing. It's an orderly and predictable function of our environment. So the real question becomes, if that's true, how can we get better at designing our environments, our homes, our classrooms, our workplaces, to make the best choices the easiest and most rewarding choices for everyone?